Hi there, welcome back. This is lesson 6 in unit 7, and today we're going to continue talking about calculations and cover concentration calculations and cover 3 different types. So ppm, mass percent, and percent volume. So in the last video, we covered one of the more important concentration calculations, molarity. We had that review of the mole mass conversion, super important. But again, today we'll talk about parts per million, so ppm, mass percent of solute, and then percent by volume. So again, this is the same slide from the other video. There are a few different ways to express solutions, or concentrations rather, so the amount of stuff in a solution. And today we're going to focus on these 3. Okay, so again, these formulas are on table T, except percent by volume, but it's very, 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 very similar to percent by mass. So you'll see what I'm talking about when we get there. So first, let's cover ppm. So ppm stands for parts per million. You might have seen it if you're, what's it called? Look into like pools and chemicals in there or different kind of gases. Sometimes you'll see ppm. So this is what it means. And so let's jump into a question. But first, this equation came straight from table T, so the last page of your reference table. So a sample question of this could be, in the United States and Canada, drinking water cannot contain more than 5 times 10 to the negative 4 milligrams of mercury per 1 times 10 to the 3 milligrams of sample of solution. In parts per million, what would that be? So again, our formula is the mass of the solute over the mass of the solution. So just remember, your solution is made up of your solute, so the thing that gets dissolved, plus your solvent, the thing that does the dissolving. So kind of keeping that in mind. So we need, and again, it's basically percent composition. It's part over whole. But if we're talking about parts per million, then you just times by a million. So another thing to point out here, that 1 million, like written like this, is the same as times 10 to the 6th. Same thing. Okay, so getting into this question, we need the mass, and our formula is mass of solute, mass of solution, times 10 to the 6th. So our mass solute, or the thing that's being dissolved, or the thing that's in the water, or the solvent, is 5 times 10 to the negative 4 milligrams. And the mass of our solution, so the entire thing, solute and solvent, says of solution. So our mass of solution is that, 1 times 10 to the 3 milligrams. And so we have both of our things. Let's just plug into the calculator. We get 5, let's bet 5 times 10 to the negative 4 over 1 times 10 to the 3. Now, if you're using a scientific calculator, use parentheses. They are your best friend. If I were you, I would do this part separately and then do times 10 to the 6th. And so when you do that, you get 0.5, and your unit is ppm, because milligrams and milligrams cancel. So your unit is ppm, and that's it. Literally just part over whole times 1 million. Okay, going into the next one, this is mass percent of solute. And so here we're going to look at mass, and so it's the mass of the solute, the thing that's being dissolved, over the total solution mass, and this is our basic percent comp formula, so it's times 100. And so here is the formula on the reference table, percent composition by mass. So let's do this question. In a solution prepared by dissolving 24 grams of NaCl in 176 grams of solution, what is the percent by mass of NaCl in solution? So our mass of our solute, so the part, is 24 grams. The mass of the solution, or the whole, is 176 grams. And so our formula is part over whole times 100. And so when you do that, you get 13.6%. If we're using sig figs, that is 14%. And that's it. Now, the way they can make this question more difficult is this. If instead of saying you have 176 grams of solution, what they could say to kind of try to trick you, they could say you have 152 grams of water. So instead of this, remember our massive solution is our solute plus our solvent. The solution is the whole thing. But if you're given just the solvent, just the water, that's not the whole thing. So we do this in red. Our mass of solute, again, is still 24 grams. That's what's being dissolved. And our solution, remember, is solute, which is 24 grams. 24 plus our solvent, which is the water, 152. And so we set up the same way, part over whole. So our part is 24. Our whole is 24 plus 152. So again, your solute plus your solvent, which is 24 over 176. Part over whole times 100. Again, you get that same thing. So it is very, very important that you read the questions carefully. If it says solution or if it says, you're a solvent, just read the questions carefully. Okay, and then last one, percent by volume. Again, this is not on the reference table, but it's very, very, very similar. Only thing we're looking at now, instead of massive solute, we're looking at the volume. So again, the mass of the part, the solute, over the volume of the solute, over the volume of the solution. And just to recap again, solution is your solute plus your solvent. So both of those things. And so let's jump into this question here. If we have 10 mils of propanone is diluted with water to form a total solution volume of 200, what's the percent by volume? So our volume of our solute is 10. Our solution is 200. So part over whole times 100. 10 over 200 times 100 is divided by 200 times 100 equals 5%. And so that is it. It's, again, literally just part over whole times 100. So you have to just make sure you're given the whole. Sometimes we have to kind of figure that out. And so let's look at this question again, but in a slightly more complicated way. So let's say it was diluted with 190 milliliters of water. What's the percent volume? So again, our volume of our solute is 10. Solution equals, solvent plus solute. So our solute is 10 mils. Our solvent is at 190 mils. So again, our part over whole times 100. So it's part 10 over 200 times 100. So same thing we were left with before, equals that 5%. So again, just be very careful if it says, what the question is actually giving you. Sometimes they'll make you calculate, just make you add the two numbers to get the whole. But that's pretty much it. In the next video, we'll cover something called colligative properties, which covers things like boiling point elevation and freezing point depression. That is it. Have a wonderful